Poor maintenance of your cooling tower can cause up to 70% of a heat transfer loss, making less profitable your industrial process. So today I'm going to show you how to improve your cooling tower's performance. First, I would like to stick up for utilities, because in this young industry where they don't care much about them and they are seen as secondary equipment, where it may be not useful to spare any technology and maintenance, making a tedious equipment operation. So if we put the right technology and maintenance in these utilities, we can control much better the industrial processes. So in cooling towers can bring many type of problems, such as fouling, scaling, and loss of the heat exchange efficiency that will directly affect your production process. So let's start by identifying which are the main contamination sources. First, we have the makeup water. In cooling tower, the water flows in a refrigeration circuit where it could get polluted by different sources. Makeup water that could not have an adequate treatment, supplying poor quality water to your cooling system. The makeup water can come from a poor well, or you have brackish water, or even from a river where the microbiological activity is high. So you will have a lot of organic particles in your system. For example, also in the Middle East, sandstorms are very frequent, so it can increase the suspended solid levels in the refrigeration circuit. Also, the same installation can be a contamination source, as pipe degradation by high and constant chemical usage will release suspended particles to the circuit. So all these particles can eventually decant and affect the water flow and therefore the heating transfer of the cooling system. So what are the types of contamination particles from these different sources? First, we have settable sludge. Mineral and organic sediments accumulation through the water circuit can decrease the heat exchange performance. For example, a 0.3 millimeter scale on the heat exchange surface will increase by 10% your energy consumption in order to achieve the same cooling efficiency. So you will need to pump more water to maintain the heat transfer coefficient. So you will have heat transfer efficiency problems. You will have a lower flow rate through the heat exchange surfaces. As the flow slows down, it is more likely that particles will decant and settle in the circuit, in pipes, and different surfaces of the system. The faster particles will settle as the flow will slow down. Then you also have scaling. Scales are crystallized depositions that are strongly adhered to the internal surfaces of the system. Once you get a scaling point, this will increase its size exponentially, as other particles are more likely to get stuck on this point, and also increasing the risk of biofouling. So poor water quality will increase the scaling, which will affect the water temperature. So the temperature will be higher. This will concentrate the salts by evaporation, so more blowdown will be needed as the concentration cycles decrease. So you will have more blowdowns, means more makeup water consumption, and also a higher environmental impact. Then you also have corrosion, which can be caused by the presence of dissolved gases present in the makeup water, and also because of the suspended solids. This, of course, will bring higher operational costs, as there will be the corrosion inhibiting chemicals will be less efficient, and you will have also cost in replacement of spare parts and main components. And also you will have, which is probably the worst, is that you have several shutdowns of the cooling tower for this for the maintenance. And finally, probably the worst of all is the biological growth. Biofouling of organic matter on heat transfer surfaces can cause up to 70% of the transfer loss. That is, the transfer loss will mean that you will have a higher energy consumption because you will have to pump more water in order to maintain the same cooling efficiency. Sometimes the environment will also help the biological growth, as the climate conditions will be ideal, and also the lighting conditions. So it will have a strong insulation action for corrosion inhibitors and oxidants. Biocidal or disinfectant to maintain residual dosing, also to avoid Legionella, as Legionella is the most dangerous bacteria for the cooling tower, which can also produce human infections and eventually the shutdown of the factory if the water contains this bacteria. So what are the benefits of having a filtration system in your refrigeration circuit? Well, installing a filtration system removes suspended solids of the cooling tower, and by achieving around 20% of chemical reduction. This has been checked in thousands of case studies. This is a very common application, and it is very easy to explain, as these suspended solids are consuming part of the biocidal or sodium hypochlorite. So by removing them, the residual disinfectant will last longer, and also the dosing will decrease, so you will have savings in chemical consumption. Of course, other benefits are implied, as the environmental impact by having less blowdown, less water consumption, and all the maintenance tasks, replacement of spare parts, consumables, etc. So what will be the most efficient solution when we're talking about filtration for cooling towers? Well, there are many options. Here we have 4 types of filtration technologies. First is the disc filtration, where each one of them have, of course, strengths and limitations, right? So let's talk a little bit about each one. The disc filtration, disc filters are made out of high-tech plastics, so you will not have corrosion problems. They have very low water consumption during backflush, also very low energy consumption, as they can work with low pressure. And the AZUD Helix automatic filter has a helix device which will delay the clogging of the filter, so the backwash frequency decreases and you have less water consumption. Screen filters are suitable for high flow rates, as they have a lower footprint. They have a robust construction, and they are ideal for high temperature applications, high pressure, and as I said, for high flow operation. Then we have the centrifugal separator, which can be also very practical, but has a very strong limitation, which is the filtration degree. It is not a physical barrier as the other technologies. It is a separation of particles, and it will efficiently remove high density and heavy particles, normally over 80 micron. Below 80 micron, the efficiency drops down dramatically, and in order to achieve 60 or 70% efficiency of removal of between 20 and 50 micron, you would need to put several stages, which makes this inefficient. The sand media filtration is probably the best filtration quality, because it also reduces turbidity, but it has a very high footprint and extremely high water consumption during backflush. The filtration quality can be improved also because you have the option of combinable media in these type of filters. And so we made this scoring table where we compare the main parameters, such as capital expenses, operational expenses, footprint, effectiveness, and operation and maintenance. As we can see, probably the most important are first effectiveness and second operational expenses. The effectiveness, we know that media filters and disc filters are probably the best, mainly because they have in-depth filtration, where they can even trap even smaller particles than the filtration degree. And during the backflush, they're the only one that during cleaning, they have an expandable media. This is, for example, the disc filter. During backflush, the discs will separate and will allow to release the trapped particles much easier than a screen, or in case of the media filter, also the media can expand during backflush, although it's much more difficult to find the equilibrium during the backflush and then to assure that the media will settle down to the same position. Also, you have the risk that part of the media will go out to the drain. And in terms of operational expenses, also the disc filter has no special tools required. It is very easy to maintain. It has a continuous operation during backflush. The media filter interrupts filtration phase during the backflush. And whoever has changed the media of a media filter knows how difficult this is and tedious, and it could even take days to finish depending on the size of the installation. So in the overall scoring, you can find that probably the best solution would be the disc filtration technology. That is why at AZUD, we always recommend in these cases, in this specific application, the disc filtration technology, where we can also supply a skid mounting solution. It is a plug and play, which helps to for installation labors. The skid includes a control unit, a PLC Siemens. It could include the feed pump in case if it's a side stream filtration, isolation valves. So you will save a lot of trouble during the installation of the equipment. Also, in disc filtration solutions, we have this exclusive air-assisted backflush that helps the efficient cleaning of the media filter, of the media, and also has 80% less water consumption than traditional backflush for disc, and even more for other technologies. So this type of solutions, as I said, have a reduction in chemical reagents consumption, provides reliability, as we're talking about a physical barrier. We will have reductions in maintenance. Your main components have extended lifespan, and of course, at the end, you have energy consumption savings. So, how do we install a filtration system? We have two options. Mainly, it is the first one is full stream. The full flow filtration uses a filter installed after the cooling tower on the discharge side of the pump. So the filter continuously filters all the recirculating water in the system, and the filter must be sized to handle the complete flow rate. So as it has to filter the complete flow rate of the circuit, you will need a larger filter, so your capital expenses will be higher. And also, there is the risk of any type of failure, or when maintenance is required, you would have to interrupt the filtration circuit and probably stop your production process. That is why we normally recommend the second option, which is the side stream filtration. Side stream filtration continuously filters a percentage of the flow instead of the entire flow. It can be a cost-effective alternative to full flow filtration that can easily improve the water quality to reduce water consumption and ensure efficiency of the cooling towers. These systems both remove suspended solids, organics, and silt particles for a portion of the water system on a continuous basis, reducing the likelihood of fouling and biogrowth, which helps to control other issues in the system such as scaling and corrosion. This improves the system efficiency and often reduces the amount of water blowdown. So you will also have the lower environmental impact. Side stream filtration systems are generally sized to filter from 10 to 10% or even up to 20% of the overall system flow. Filters are selected based on the percentage flow of the side stream filtration as the system is designed to handle. Right? For example, in a cooling tower with a recirculation rate of 1,500 cubic meter per hour, a filtration system sized to handle 10% would the recirculation rate would be sized to handle only 150 cubic meter per hour. So, in conclusion, these would be the main benefits of a filtration system. First, you have a reduction in water consumption, where you have a lower demand for makeup water, increasing the system's concentration cycle. Essentially, higher concentration cycles mean that water is being recirculated through the system longer before a blowdown is required. The less blowdown reduces the amount of makeup water in the system and also lower environmental impact. Second, you have reduction in energy consumption, as side stream filtration reduces the likelihood of scale and fouling in the heat exchanger surfaces. Even the smallest layer of scale or fouling on the heat exchange surfaces can reduce the heat exchange rate, forcing the system to work harder to achieve the desired cooling and in turn increases energy costs. Also, you have a reduction in chemical use. Chemicals are used to bind suspended solids in the water stream and prevent scaling and corrosion. Dirty water requires more chemicals than clean water because the buildup of solid contaminants provides a buffer that reduces the effect of the chemical treatment. A side stream filtration can remove suspended particles and reduce the need on any additional chemicals treatment, such as dispersants or biocides. Also, very important, you have a lower maintenance cost. Traditionally, cooling towers are cleaned by draining the tower and having the sediment removed either mechanically or manually from the sump. The costs associated with this cleaning process include downtime, labor, loss of water, and additional chemicals. So chemical systems that are clean with a side stream filtration routinely provide longer period of continuous operation before being taken offline for required maintenance. And finally, you have an improvement in your productivity process and a reduction in downtime. When a cooling system is fouled or has scale buildup, production may be slowed due to inefficient heat exchange equipment. In some cases, the cooling system and heat exchange equipment may need to be taken offline for repairs, decreasing your production. The control of biological growth and reduction can mitigate potential health problems also, such as those caused by Legionella. The use of a side stream filtration can minimize habitat surfaces and nutrients by maintaining lower particles levels in the water stream. So finally, I want to show a little bit about our experience. First, we have this success case of a district cooling plants in Dubai, where this company had a very big cooling tower for their processes, and due to the fact that there were many sandstorms, cooling system increased the suspended solids and the turbidity, which made nebulizers to clog. Also, there was blockage of the cooling system panels. And of course, there was a high microbiological growth in the system. So maintenance time and spare parts increased, and there was a decrease also in the heat transfer of the cooling tower. This company trusted in our solutions to solve the problem. So we installed a disk filtration side stream system, and we decided to monitorize the water quality with a turbidity meter. Before the installation of the disk filter, the value was up to 350 NTU, and only after 20 days of the disk filter working, turbidity went down dramatically to 10 NTU. So we obtained removal of more than 90% of the TSS in the tower. So sandstorms were no longer a problem. We decreased the maintenance, which used to be 4 to 5 hours per week because of the problems caused of the sandstorm. We increased the lifespan of nebulizers and panels, and all of this with a return on investment in less than 2 years. So as you can see, only installing one filtration equipment in this big cooling tower meant a relief for the factory and important savings in terms of money for the DCP. The next case study is in Mexico, and this company had 3 cooling tower systems with different sizes for each of their processes. High load of organic matter was constantly contaminating all the cooling water circuit. So the maintenance team was only using chemical reagents to control the water quality, but even though there were many unscheduled shutdowns. Due to the very poor water quality, the chemical usage was not enough to maintain an optimal performance of the cooling tower. As they had a massive water consumption by frequent blowdowns, so very high makeup water costs, and of course, a very high environmental impact. So the main problems here that we were facing was the high chemical consumption, and the fact that it was not possible to maintain a constant water quality. With all these problems, AZUD was contacted to improve the performance of the refrigerator system. Our proposal was a side stream filtration for each system of 10% of the total volume at 50 micron. By this way, we managed to maintain TSS levels below 5 ppm by removing the suspended solids. After the AZUD disk filter installation, the company achieved to reduce the chemical reagents and makeup water, improving the cooling system performance by an average saving of 23% of chemical reagents in their 3 cooling towers, 50% reduction in their downtimes, and all this with payback less than 2 years. At the end, AZUD filtration solution helped the company not only in terms of operational costs, but also allowed them to focus their efforts on their own production processes and not just the utility performance. Finally, I wanted to show you this case study that also is a side stream filtration at a petrochemical industry. But the interesting thing about this reference, it is a containerized solution. It is the environment was not the best, as in the winter we had extreme temperatures reaching down to minus 35 degrees Celsius. So the container was isolated and had a heating and ventilation system in order to maintain a constant temperature between 18 and 21 degrees for the correct operation of the filter. The containerized solution helps to also installation issues. It is also a plug-and-play solution. It's what we call a decentralized solution. So in this case, The benefit of the application was that also we decreased the chemical consumption. As you can see in the first table, that these are liters per year of chemical usage. With the disc filter, we reduced from 1,000 liters per year to 800. And also the energy consumption was improved with the filtration system. On the table of the right, you can see that without the filtration and the presence of biofouling, the energy consumption was very high, and this was solved only with a side stream filtration. So, as a conclusion, you can say that a correct water filtration design can eliminate these risks by removing the suspended solids present in the cooling water circuit, and self-cleaning disc filtration technology can provide a cost-effective solution, contributing for a greener environment and for a circular economy. So thank you very much to all of you for your attention. And David, if it's okay, we can move forward to the Q&A. And so
yeah, thank you very much, Ignacio. Very interesting, especially with those different case studies that that we can see across the globe. At the moment, if you want to ask a question, by all means, please put it down there in the chat, and I'll be able to read it out to Ignacio, and he'll be able to answer that for you here. As we don't have any just yet in the chat, Ignacio, I do actually have one myself, and I can see from the different implementations of these technologies, and obviously with regards to total dissolved solids as being some of the bigger issues that you need to solve. I kind of wondered to myself, what would be the most complex waters that this type of technology could actually treat? How complex and how difficult these waters can be that could actually be treated by this technology.
Okay, thank you very much, David. Well, the complexity of the water, you can have very difficult water, even so difficult that you will need another type of technologies. But if we remain in suspended solids, which is what the disc filter and other technologies that I mentioned do, probably the most difficult waters are the ones that have industries such as pulp and paper, where you have many sticky particles, or even textile, where you have filamentous particles. And the main issue is that once you filter the particles, you have to flush them, you have to clean them. So the recovery of the filtration media is very difficult. That is why we always recommend the disc filter, because the filtration media is expandable, and this will help to release these sticky particles that could be, as I said, in cases like pulp and paper, textile, or even when the makeup water, for example, comes from a river, you will find a lot of organic particles as well, which can adhere very strongly to the filtration media, making it very hard to recover. So again, that's why I say I would not recommend, for example, a screen filter that has not an expandable media. So it will normally depend on the nature of the particle. I think that that answers your question. Well, in case if you have even more difficult, like it could be seawater, you would also need a desalination system with the RO, but that is another type of technology that's for different purposes. It's a complementary technology.
Thank you, Ignacio. Yeah, very interesting. I think it's clearly quite powerful, this technology, especially when you talk about paper and pulp industry. Definitely a difficult and complex waters to treat. So yeah, very interesting to hear that response.
Well, it's actually, as I said, the pollutants come from the industry, or from the environment as well. So if your factory is, for example, located in a forest, they will have a lot of pollen and organics that are very also very difficult to clean. So it can come from many places, but those are the most difficult type of waters. And that is why an expandable media is always recommended for this type of solutions.
Thank you, Ignacio. If you do have any questions for Ignacio, then please, by all means, you can ask them here in the chat or indeed on the app. And I'm sure that Ignacio can reply to you there. So thank you, Ignacio. And
absolutely.